we're going to look at the relationship connecting a sector and a cone. So on the left hand side we have a sector, and on the right hand side we have a cone formed from that sector. So for us to form this cone, if we join the length of arc AB, so if we join A to B, we'll notice that we'll have this shape. So this is a sector, while after joining A to B, a cone will be formed. Yes. And if we call the radius of the sector L and angle, the central angle, let's call it theta. So we'll notice that after we've joined AB, see, a cone will be formed, and we know a cone will have a radius and also a perpendicular height. So if you introduce the height, the perpendicular height, let's call it H, while the radius R, and you know the two are perpendicular. So we see that OAB, that's this length, is the radius of the sector. Yes, check. If we join this will come up to have point A. The vertex of the center becomes the vertex of the cone. So that's what we have. So let's now get some. We have 5 formulas we're going to generate from this. That's 5 relationships. So we see that by joining AB is this arc, length of arc. Yes. So we see that AB, which is the length of arc, minor arc AB of the sector, arc of the sector will now form the circumference of the base of the cone. Yes. We now have circumference of the base of the cone. Yes. Check. Now by joining this, it would complete a circle, so making a circumference. And we know that sector of a circle is always the angle over 360 times pi, the radius 2 pi the radius. That's 2 pi times the radius, and the radius is L. L is the radius of the sector, while circumference of a circle is 2 pi r, which is the radius of the cone. So what you have to say, 2 pi is common, so you see that the ratio of the radius of the cone to that of the sector will be theta over 360. So that's the first formula we've generated. That's the first thing. So look at the second one. We know that the area of this sector will become the curved surface area of the cone. Yes. So area of the cone will now be curved surface area. Curved surface area of the, okay, we'll have a lot of area, so let's write it for our curved surface area. We see that curved surface area of the cone will give us the area of the sector. That's the same material, so if the area of the sector is the same as the curved surface area of the cone, and we know that the sector, the area is theta over 360 times pi radius squared. And since we've generated the relationship theta over 360 is the same thing as r, because we want to introduce the radius of the cone, so r over l times pi l squared. So what do you have to say? We now see that the curved surface area of a cone is pi r l, where r is the cone, the radius of the cone, l is the radius of the sector. So that's the second formula. Again, we can still get the area, since curved surface area of the cone is pi RL. And we know, if you look at the number 1, we say that the length of arc is equal to 2 pi r. So if I make pi r the subject of formula, we'll see that is now the length of arc over 2. Yes, that's pi r. Check this one. From theta over 360 times 2 pi l equals 2 pi r. That's length of arc equals 2 pi r. So making pi r the subject of formula, we see that it's now length of arc over 2 times l. So again, we've known that the curved surface area of a cone is always equal to half times the length of arc of the sector times the radius of the sector. So we've generated the third formula. The fourth formula, since we've known that the area of the sector and the area of the cone are the same, so it's possible they can give you the cone to form a sector. So we'll see that area of the sector will now be equal to curved surface area of the cone. Yes, which is pi r l. And from the diagram, using Pythagorean theorem, this is the same as pi r is square root of, that's using Pythagorean theory, we now have h squared plus r squared. So that's the fourth formula. Because it's possible they can give you the radius of the cone, the height of the cone, and ask you to find the area of the sector that will be formed with that. So finally, the volume of a cone is always equal to 1 over 3 pi r squared. Okay, this 3. Okay, let me use I. So the final stuff here, which is V, volume of a cone is always 1 over 3 pi r square h. And from here, we've noticed we can get, using Pythagorean theorem, we can see that this is 1 over 3 pi r square, the square root of l squared minus r squared. That's from Pythagorean theorem, from the cone. So these are the 5 formulas that we use in solving questions that involve sector and a cone. So let's look at this first question. It said a sector of a circle of angle 2 phi is bent to form a cone. What is the ratio of the, so without wasting time, the ratio of the radius to that of the radius of the cone to that of the sector is theta, which is 240 over 360. So the answer is 2:3. Yes, that should be option B. The second question, they said the curved surface area of a cone formed from a sector of radius 4 cm and length of r. So we've noticed that, or we've observed, or we've derived that curved surface area of a cone is always half times the length of arc of the sector times the radius of the sector. So without wasting time, our answer is half times 44 times 4, so which is 8. So that, what is the volume of a cone from a sector if the sum and the difference of their radii are 25 and 9 cm? So we've generated that the volume of a cone is always 1/3 pi r square, the square root of L squared minus R squared. Yes, we've done that. And since they gave us the sum and the difference, so we convert this to difference of 2 square, which is L plus R times L minus R. So this is 1/3 pi. Okay, we've done known R. We don't know R, so but we can get it. They say that L plus R, L plus R is what? 25, and L minus R is 9. So equation 1 and equation 2. So subtracting equation 2 from 1, we have 2R is equal to 16. Yes, that is equation 1 minus equation 2. So we see that R is 8. So we have 8 squared is 64 times square root of 25 times square root of 9. So this is 8, 1/3 pi 64 times 5 times 3. So this is 64 times, that's 320 pi. So that should be option A. Why the final question? They said an open cone with base radius 28 cm and perpendicular height is stretched to form a cone. Calculate the area of the sector. So the area, we've proved that the area of the sector is equal to pi r square root of h squared plus r squared. Yes, and this is now pi 22/7. Since the answers are not left in pi, r is 28, while the height is 96. That's 96 squared plus 28 squared, and this is 22 times 4 times, I have a perfect square which is 4. So 4 here, 4 squared. So square root of 4 squared is 4 times, we are left with 24 squared. Yes, because 4 times 24 is 96. So we're left 24 squared plus 7 squared. Do you get? Both of them have 4 as a factor. So I factored 4 squared. But 96 is 4 times 24, while 28 is 4 times 7. So this is 22 times 4 times 4 times, this is square root of this 625, which is 25. So the answer is 8800 cm squared. Yes, so that is option C. So have you seen how we use the formulas, the 5 formulas to solve these questions? Thank you.